how can proportional reasoning help solve a problem? Think about whether a problem involves a proportional relationship before you apply your knowledge of proportions and ratios to solve it. So let's see whether you can use your knowledge of ratios and proportions to solve this problem. Deshaun and Stephanie both collect baseball cards. You can see that Deshaun has more cards than Stephanie. The ratio of collectible cards Deshaun owns to cards that Stephanie owns is 5-2. Stephanie has 36 cards. How will the ratio of Deshaun's cards to Stephanie's cards change if they both sell half their cards? How can you use proportional reasoning to compare the quantities of cards? Step 1. Draw a diagram that represents the ratio of Deshaun's cards to Stephanie's cards. We know that the ratio of Deshaun's cards to Stephanie's cards is 5-2, and that Stephanie has 36 cards. Use the diagram to find the number of cards Deshaun owns. How many cards are in each stack?
Select your answer.
Since Stephanie has 36 cards, each stack has 36 divided by 2, or 18 cards. Stephanie has 2 stacks of 18, so Deshaun has 5 times 18, or 90 cards. You can also use equivalent ratios to find the number of cards Deshaun has. Step 2 is to find the ratio after they sell half of their cards. You can represent this in the diagram by replacing each 18 with a 9. So, Stephanie now has 18 cards and Deshaun now has 45 cards. You can use a table to organize the information. After they both sell half their cards, the ratio is 45-18. Notice that the new numbers of cards are each 9 times the term in the original ratio. The numbers of cards changed by the same multiple, so the ratio that relates them is equivalent. It's still 5-2.
After selling half their card collections, Deshaun and Stephanie each buy 9 new cards. What is the ratio of the number of cards Deshaun has to the number Stephanie has?
So now we have to look at adding these new cards. Based on the example, Deshaun, after selling his cards, had 45, and Stephanie had 18 after selling off half. And now they each bought 9 more. So let's add 9 more to each person. So 45 and 9, that's 54. And 18 plus 9 is 27. So now we need a new ratio, and we want a simplified ratio. So we're going to find the greatest common factor and divide by that number. That would be 9. So we're going to divide the top and the bottom by 9. 54 divided by 9 is 6. And 27 divided by 9 is 3. That could actually be simplified further. You divide that by the greatest common factor of these two, which is 3. And then 6 divided by 3 is 2. 3 divided by 3 is 1. So our new ratio would be 2-1.
Martin is 6 years old when his sister, Cassandra, is 3 years old. How old will Martin be when Cassandra is 6 years old?
So we look at the table, and they made a table of Martin's age and Cassandra's age over the years. As you can see, to go from 3 to 6, you would multiply by 2, and that gives us 6. And then you multiply by 2 and 6, you get 12. So that wouldn't work. So 6 times 1.5 equals 9. So because these numbers are not the same, or they're not a constant multiple, we cannot use proportional reasoning. We can still answer the question, but we can't use proportional reasoning. So when Martin or Cassandra's 6, Martin will be 9 years old.
A video streaming service charged Brian $143.84 for a full year of access. Brian thinks he was not charged the correct amount. What should Brian say when he calls customer service? Write an equation to represent the situation. The rate is constant. It is $8.99 per month. The cost is always a constant multiple of the number of months. So an equation that represents the cost y after x months is y equals 8 99/100 times x. Substitute the given information into the equation and solve. Write the equation. Substitute 12 for x. Then simplify. Brian should have been charged $107.88. He should ask customer service for a credit of $143.84 minus $107.88, which is $35.96. Write the equation. Substitute 143 for y. Next, divide each side by 8 99/100 and simplify. Brian was charged for 16 months, so he should ask customer service to give him 4 months of free online service. There are 2 options for what Brian can say when he calls customer service. A florist makes bouquets that include 50 orange blossoms and 7 hibiscus. If the florist orders 1,050 orange blossoms and 140 hibiscus, there will be leftover flowers. How can the florist adjust the order so there are no leftover flowers?
So just the same as the example, we are going to have 2 options. So option 1, we're going to put our ratio of 50 orange blossoms to 7 hibiscus flowers. So we have 50 over 7. He orders 1,050 orange blossoms and 140. So we have 1,050 over 140. And we want to know if these are equivalent, right? So we have to consider that 50 orange blossoms. So let's see, 50 times what will get me close to 1,050. 50 times 21 is equal to 1,050, but 7 times 21 is not 140. You actually have to multiply 70 times 20 to equal 140. So because these 2 numbers are not proportional, that means like it said in the problem, we would have to adjust. So that they are proportional, we can multiply the top number by 20 as well. So let's change that 1 to a 20, and then 50 times 20 would actually give us, I'm going to write it over here, 1,000, and then 7 times 20 does still equal the 140. So the florist could adjust the number of orange blossoms from 1,050 to 1,000, and then that way there would be no leftover flowers. And option 2, in this case, it would actually not be an option 2 now that I'm looking at it, because our relationship here was not proportional, or this is not it was not a constant to begin with. We don't have a second option, so his only option would be to reduce the number of orange blossoms so that he does not have any leftover flowers.